Hey, welcome back. This is Math 0965. This will be a section on applications. And so let's take a look. Okay. So the first section are motion problems. So we'll begin with motion. And the formula for motion, distance equals rate times time. Okay, so D for distance, R for rate, and T for time. So for example, if I drove 60 miles per hour for 3 hours, that would tell me a distance, right? So the D equals the rate, 60 miles per hour, times the time, 3 hours. Sorry about that. So I would have traveled 120 miles. Okay, that's the form we're used to seeing it in. And for this book, what we're going to do for this section in this book, what we're going to do is divide both sides by r and sort of create a new equation, quote unquote new. But anyways, so dividing by r, we get t, or d over r equals t. But let's flip flop the sides and get t equals d over r. Okay, so that will be the form we use. Let's dive right in and look at one of these problems. This is checkpoint 1 in the book on page 549. I'll just write checkpoint, check, CHK for check, checkpoint 1. And you might want to have your book open. You might want to pause the video and get your book so you can see this problem. But I'll speak it out anyways. Where are you? Checkpoint 1. Okay, so it says it says something silly, and then it says the time we have, the time you're canoeing on the Colorado. Okay, this time you're canoeing on the Colorado River, so you kind of had to read the question before it to understand what the heck they're talking about. Anyways, apparently you're in a canoe, and you're on the Colorado River. Okay, in still water, your average canoeing rate is 3 miles per hour. It takes you the same amount of time to travel 10 miles downstream with the current as it does to take 2 miles as 2 miles upstream against the current. What is the rate of the water's current? Okay, so the first thing you're probably going to do is kind of set up a chart. So you're going downstream with the current, which means you'll be going a little bit faster, and you're going upstream then against the current, which means you're going to be going a little slower. Okay. Then we're going to do this kind of table where I'm going to put the variables from our formula for motion in the first row. Okay, so we have D, R, and then T. And for T, we're just going to take whatever we find for D and put it all over whatever we find for R. Okay, so let's read the question again. It says, in still water, your average canoeing rate is 3 miles per hour. It takes you the same amount of time to travel 10 miles downstream with the current, so 10 miles with the current, as it does for you to travel 2 miles upstream against the current. Okay. So the rate, we want to know the rate of the water's current. And it's telling me in still water, your average canoeing rate is 3 miles per hour. So if you're going with the current and you're in a canoe, so here's my canoe. If you're going with the current, it's going to be your canoe's rate, which is 3 miles per hour, plus the rate of the current, because you're going a little bit faster. It's like there's this water, it's pushing on the boat, and it's making you go faster. So we'll go plus X. So it's 3 plus X, which maybe we should even say X is the current of the water, the speed of the water. Okay. And then when you're going against the current, the water is pushing against the boat, and it makes it go a little bit slower. Okay. So again, we have this picture. The water is pushing against it, so you have the speed of the boat, and then minus the speed of the water. Okay, so the rate when you're going against the current is 3 minus X. Then everything else is kind of just automatic. Automatically, we know the time is distance, which is 10 over the rate. Going against the current, it's 2 all over the rate. And then I kind of go back to the question to find my equation. Okay. And it's in this sentence that says it takes you the same amount of time to travel 10 miles downstream with the current as 2 miles upstream against the current. So what they're saying is that this time, which is given by this expression 10 over 3 plus x, is the same as the time given by this expression 2 all over 3 minus x. So we're going to have 10 all over 3 plus x equals 2 all over 3 minus x. Okay. From here, then we know how to solve these kinds of equations. Just multiply both sides by the common denominator. One other thing which they do introduce in this section is called cross multiplication. Okay, so you'll see it in the book. It'll say if you have what we'll call ratios here later on being equated in this proportion. So if you have A over B equals C over D, that means that A times D is equal to C times B, and that's called the cross product, I believe, in the book. Let me make sure that's what they call it. Everybody has to call it something different, you know. Let's see if I can find it. Yeah, they call it cross product. Okay. Okay, so 10 times 3 minus x on one side, and on the other side we'll have 2 times 3 plus x. Okay. So distributing here, we get 30 minus 10x. Distributing here, we get 6 plus 2x. And then I want to solve for x, which is the speed of the water. And usually if you read the last sentence, that's kind of what you're after. So it says in the last sentence, what is the rate of the water's current? So yeah, it's this x value that we're after. Okay, so I'm going to move the 10 to the right, move the 6 to the left. I get 36 is equal to 12x. Just divide both sides by 12, and you get x is 3, which is the speed of the water. Okay. Okay, let's go over to my math lab and see if we can pick out some of these types of motion problems. All right, so the first question they give you here, they kind of give you there's always going to be these two things, right? So in this one, it's walking versus driving. Okay, and they already set up the chart for you. This one, you're going downhill versus going uphill. Okay. This one is another rate of the water problem. Okay. Let's try this one. Okay. Well, no, let's not do the same one. Let's sorry. Sure, let's do the boat one again. And we want to make this one the video quiz question. That's I kind of already set this one for the video quiz, but I don't want to do it because exactly, you could never win. Okay, so anyways, in still water, the boat averages 12 miles per hour. It takes the same amount of time to travel 4 miles downstream with the current as it does 2 miles upstream against the current. What's the rate of the water's current? Okay. So again, do your table. So we're going downstream is with the current, so I'll write with the current, and then against the current when I'm going back upstream. And then you have your D, your R, and your T, which is equal to D over R. Okay. The distance you're traveling with the current, it says 4 miles downstream with the current, so 4. The distance traveled against the current, 2 miles upstream against the current. And then the rate, so the boat itself is going 12 miles per hour. And if you're going with the current, it's going to be 12 plus whatever the heck the rate of the current is, which we don't know. So we'll just call that x. If you're going against the current, it's going to be 12, and then you subtract away the water pushing against the boat. Then finally you have 4 over 12 plus x, and then 2 over 12 minus x, and then go back to the question to form your equation. So it's the second sentence here. It says it takes the same amount of time. The same, that word same means equal. The same amount of time to travel 4 miles downstream with the current as it does 2 miles upstream against the current. So again, the same sort of problem. This thing here is going to equal this thing here. All right. All right, so then I'm going to cross multiply like that. So it's going to be 4 times the 12 minus x on one side, and then 2 times 12 plus x on the other. So I distribute here. I get 48 minus 4x. On the other side, I get 24 plus 2x. I'm going to move the 4x over, move the 24 over. I'll get 48 minus 24 is 24. The other side, 4x plus 2x is 6x. Divide both sides by 6, and you got x equals 4 miles per hour. Okay, so that's our video quiz question. I usually don't use my math lab problems, but this time I did. Okay, so video quiz, video quiz, video quiz. They're not always going to be that easy. So, you know, sometimes it's like they'll give you like a prescription. It's like you go to the doctor and you know you got a cold, so you take I don't know, antibiotics or whatever, right? What we're doing here is kind of giving you the antibiotics. These are, you know, when you're up against this kind of problem, use this antibiotic and it will solve the problem. And in the real world, though, it's not like that, right? You're not going to be able to do prescriptions like this. It's more like you'll think about what you did in college and say, well, this is a little like that problem, or this is a little like that problem. But ultimately, every problem is kind of unique, right? So, you know, we're giving you ways of combating all this stuff, but when it comes right down to it, it's really, you have to think for yourself. You know, if it wasn't like that, we just program a computer to do your job, you know. So yeah, you know, don't take these story problems too seriously, because in the real world, you know, everything's unique. But if you know nothing, if you have nothing on your plate, at least we're going to give you something that you can kind of look back on and say, well, this is kind of like that problem, or it's kind of like this problem. Okay, and you get some practice doing algebra along the way. All right, so anyways, there's that, my little spiel on there. Let's look at some other, there's some weird ones in here. Oh yeah, so this one, this is on jogging. So you jog 3 times. Okay, so first you're walking and then you're jogging. So it says part of an exercise regimen, you walk 6 miles, then you're going to jog, and you jog 3 times your walking speed for another 6 miles. Okay, so there's a jogging part. Let's put the walking first. Okay, there's always these two like issues that you put in your rows, and then up top you have DRT, D over R. They're all kind of the same problem, but again, you know, they can make them annoying. Okay, so anyways, you're walking. How far did you walk? 6 miles. Then you jogged for another 6 miles. We don't know the walking or the jogging rates. If you look at that last kind of part, find the walking and the jogging rates. We don't know either one. So let's call the walking rate X. And then it does give you information about the jogging rate. The jogging rate is 3 times the walking rate. So you see that phrase right there. In other words, the jogging rate is 3 times the walking rate. In other words, 3 times X, 3X. Okay, and then you automatically get your time expressions. We could simplify the second expression, 6 over 3. You could factor and then simplify if you wish. You can remove the 3's, just get 2 over x. Okay, then we want to set up the equation. So the last 2 problems, all we had to do was equate the time, and this problem is different though. It says if the total time spent walking and jogging is 4 hours, find the walking and jogging rates. So what they mean is that the time it took to walk plus the time it took to jog is equal to 4, the total time. So in other words, 6 over x plus 2 over x is equal to 4. We can multiply both sides by the common denominator, x. the LCD. And so here, x times 6 over x is 6. X times 2 over x is 2. On the other side, you have 4x. So 8 equals 4x. So x equals 2. And so the jogging rate is 2. And then the walking rate is a slower rate. That would be 2. That's x is what we just found. So that was the walking rate. And then 3 times x is 6. That should be the jogging rate. Okay, great. This one was a little weird in the setup. So again, it's a boat going upstream and downstream, but it don't tell you which one is going with the current, which one's going against the current. Okay, you don't really know. You just kind of have to logically deduce which is which. Okay, so I'll just set it up for you. I won't do the whole thing. So we're traveling 1 mile, so we don't know which is which, right? But think about it, right? 1 mile upstream in the same time it takes 11 miles downstream. So you must be going much faster downstream. In other words, when you're going downstream, that's when you're traveling the 11 miles. And then when you're going upstream, that's when you're going against. So you're going slower, so you don't travel as far. Okay? And we're assuming these are both the same. It takes the same time to travel 1 mile upstream as it does to take you 11 miles downstream. Okay? And then what is the speed of the boat? The boat speed is given as 5 miles per hour. So when you're going with, it'll be 5 plus the speed of the water. Or no, they're giving you the speed of the water. So when you're going with the stream, it's going to be the speed of the boat, which we don't know, plus the speed of the water, which is 5. And then when you're going against, it'll be x minus 5, and then you get your 11 over x plus 5, and your 1 over x minus 5. So I'll go ahead and do it. And then it's saying that it takes the same time in both cases, so you just equate the times. So you get 11x minus 55 when you multiply those equals x plus 5, and then move the x here. So it's 10x equals 60, so x is equal to 6 for the speed of the boat in still water. Okay, 6 miles per hour. Let's see if they have any other weird ones on this issue. That's the next kind of problem we're going to look at. That's a ratio. We'll look at that here in a bit. There was one weird one. I just want to find it. These are I think it was at the end. Sorry. These are some of the weird kind of questions. Determine whether a statement makes sense and explain your reasoning. It took me the same amount of time to travel 10 miles with the current as it did to travel 15 miles against the current. The problem with this is if you're going against the current, you're going to be going slower. So there's no way you could travel 15 miles when you're going against the current as 10 miles when you're going with the current. Okay, because you'd be going slower. So there's no way you could go 10 miles against the current in the same time it took to go 10 miles with the current. So that one's just does not make any sense. Okay, so those are some interesting questions. Here's one. A snowstorm causes a bus driver to decrease the usual average rate by 120 mile route by 15 miles per hour. As a result, the bus takes 4 hours longer to complete the route. At what average rate does the bus usually cover the 120 mile route? Okay, so snow versus no snow. And then we get our distance equals rate times time, where time is distance over rate. So it's a 120 mile route in both cases. The average rate with no snow, we don't know. At what average rate does the bus usually cover? We don't know. But we do know with snow, we have a decrease in the usual average rate. So that first sentence here it's decreased by 15 miles per hour. So it'll be the usual rate minus 15. Okay. Then we have x over 120 and x, whoops, I got that flipped, 120 over x, and then 120 over x minus 15. Okay. Okay. So then we need an equation. So it says, as a result, the bus takes 4 hours longer than usual to complete the route. Okay. So the time when you're taking when there's no snow is 4 hours. No, the snow time is 4 hours longer than the usual time. So if you added 4 to the usual time, that would equal the amount of time it takes when it's snowing. Okay. So the no snow time plus 4 more hours would equal the amount of time it would take if it was snowing out. And then you solve this equation. Okay. So let's do it. Make sure it works. I need to multiply both sides by the LCD. So in this case, it's x times x minus 15. Distributing here on the first term, the x's will cancel, and you're left with 120 times x minus 15. Then these, you'll have plus 4 times x minus 15. No cancellation there. On the right, the x minus 15's cancel, so you get 120x. And so distribute 120x minus 15 times 120. $1,800 plus 4x squared minus 60 equals 60x. I lost my x there. Equals 120x. Okay. Combine like terms. So what do we have? 4x squared plus 60x minus 1,800 equals 120x. Subtract the 120 over 4x squared minus 60x minus 1,800 is 0. Divide everything by 4. So get x squared minus 15x minus 450 equals 0. And then x plus x minus, I'm thinking 45 and 10 would have been nice, right? We need two numbers that multiply that give me 450, but then subtract that give me 15. 45 and 10 won't work. So it's 45 and 10. I'm just going to look at the factors and then kind of rearrange them. 9 and 5, and then 5 and 2. So 18 and 25. So if I this times this, and then this times this, it's 25 and 18. Then subtract them. That's not going to work, right? 1, 18, 7, no. Let's see, 10 and 45. Yeah, I already did that one. How about 15 and something? It's 450 divided. So it would be 3 times 3 times 5 times 5 times 2. So you could group like 75 and 6 won't work. 15 and 30. There it is. So 15 here, and then the leftover bits, 3 times 5 times 2 is 30. Okay, so it'd be x plus 15, x minus 30, set each equal to 0. The only one that works is the 30. This will be negative. So thinking 30 miles per hour. Of course, I don't know because I've not done this problem yet. Yay. This is a different kind of problem. And that's a different one. Okay, so that's our motion problems, the big and the small of it. Let's move on to the next type of problem, which is on work. And usually it's given in this kind of form, x all over a plus X over B equals 1. So basically the part that worker 1 does plus the part that worker 2 does equals 1 full job. Okay, so what we're thinking about is two people that usually work separately working together to finish a job. And X will represent the time it takes both people to do the job. A will be the time it takes one person working alone. B will be the time it takes person 2 working alone. And then that's pretty much it. Okay, so let's look at one of these problems. Where did my questions go? Here we are. Okay, so here's a typical kind of problem. Number, you can kind of tell what number it is, 7.7.51. It normally takes 3 hours to fill a swimming pool. The pool has, though, developed a slow week. Well, this one might be a little more complicated. Obviously, it's a little farther down the list. Let's go back a little bit. Okay, sorry about that. There's a pool question, I missed it. Okay, so this is like question 15. A pool can be filled by one pipe in 5 hours and a second pipe in 9 hours. So A is basically the time it takes the pipe 1, and B is 9, the time it takes pipe 2 to fill the pool, working by themselves. So now they're asking how long does it take using both pipes to fill the pool. Okay, so you'll go X over 5 plus the part done by pipe 1 plus the part done by pipe 2 is equal to 1 full job. Okay, and then just solve that for X. Believe it or not, it works. Okay, so multiply both sides by the LCD. Here it's 45. Okay, so I end up with 9x plus 5x equals 45. This will be 14x is 45 divided by 14. And they want to the nearest tenth. 3.2. Okay, so they're kind of just plug and chugs. They'll try to make them more complicated, and you can have two people kind of working against each other. So those scenarios, all you have to do is change a plus to a minus, though. But let's look at one more. This, where is it? Oops. I don't want to see that. Okay, a crew will arrive in 1 week and begin filming a city for a movie. The mayor is desperate to clean the city streets before the filming begins. 2 teams are available, one that requires 600 hours and one that requires 500 hours. So your A this time would be 600, your B this time would be 500. And the teams, how long it will take for the teams working together to clean the streets. So you just go 600, x over 600 plus x over 500 equals 1, and then multiply by the LCD. In this case, 500 and 600. 500 is just 5 times 100. 600 is 6 times 100. So this guy would be, they both have 100. The guy on the left's missing a 6. The guy on the right's missing a 5. So it would be 5 times 6 times 100, which is 3,000. Okay, so just multiply by 3,000. Distribute. Okay, so you'd end up with 5x plus 6x equals 3,000. 5x plus 6x is 11x. Divide by 11. You get 272.7 hours. They want to know, so they have 1 week before the film crew arrives and starts filming. Is that going to be enough time? So you got to figure out how many hours are in 1 week. So 1 week has 7 days, and in each day there are 24 hours. So just multiply that. 8 carry the 2, 140, 14 plus 2 is 168. So we only have 168 hours. It takes 272 hours. So no, we're not going to have enough time. Okay. So that's the big and the small. Let me see. There was like one complicated one towards the end here. 24. Ben can do a company report in 4 hours. Shane can do it in 2.4. Well, that's the same kind of. Well, no, they want 8 company reports. Okay, so Ben can do it in 4, so that would be your A. Shane can do it in 2.4, so that would be your B. So the time for one job, for one report, would be x over 4 plus x over 2.4 equals 1 full job. Okay, 2.4 is the same as 2 and 4/10, which is the same as 24/10, which is the same as 12/5, which then we could rewrite this as x over 4 plus x over 12 over 5 equals 1. Get rid of that complex fraction. So this is x over 4 plus x divided by 12 over 5 equals 1. And then you can rewrite that as multiplication. So you have x over, this might be going above and beyond. Probably could have just multiplied everything by 4 times 2.4. That would have been easier. I don't know. Anyways, 5 over 12 equals 1. So you have x over 4 plus 5x over 12 equals 1. In other words, you just kind of take this and take the reciprocal of it. 1 over, 1 all over 2 all over 3 is equal to 3/2. 1 all over 7 all over 8 is equal to 8/7. You get it? Okay, well, hopefully, I don't know. Okay, so anyways, now you can multiply by the LCD. It's a little easier to do in your head at least. But in the beginning, you could have just multiplied both sides by 2.4 times 4, whatever that is, 6 carry the 1, 9.6, multiply both sides by 9.6. That would have been the same. I don't know where I was going with that, and I apologize. 12 times x over 4. 4 goes into 12 3 times, so you get 3x plus 12's cancel, it's 5x. So 8x is 12, and then divide by 8. So you get 12 over 8, which is 3 over 2. But that's only for one report, and they want 8 reports. Okay, so you're going to have to go 3 over 2 times 8. So 2 goes in 8 4 times. 4 times 3 is 12. Okay, so 12 hours. Excellent. Okay. This is one of the ones where I think it's subtracted. Okay, so it normally takes 3 hours to fill a swimming pool. Okay, so you can kind of think of there's a pipe going in, and its time to fill is 3 hours. But then there's this other pipe there's this leak, and you can think of it as another pipe kind of leading out of the pool. Okay, so I guess they're telling you if the thing was full. Jeez, I'm not even sure how to approach this one. I think you want to set it up like a subtraction. Like it takes the other guy kind of 12 hours, but in the other direction. It takes 12 hours to clear out the entire pool. If the pool is full, it'd take 12 hours for all the water to leak out. So I think you want to set it up like minus, like they're working against each other, right? And then set that equal to 1. So it's just like the other ones where you're going plus, but now because 1 is kind of not helping, but rather hurting, you're going to put a minus in there instead of plus. I think that'll do it. Let's roll the dice. Okay, so I'm going to multiply everything by 12. And distribute, so I get 4x minus x equals 12, so 3x equals 12, and then x will be 4. I hope it's right. 4? Yay, I got it. Okay. So sometimes a minus if they're not working together, but rather working against each other. Okay, let's move on. So that's work. The next thing are proportions. And these are equations where you have a ratio on each side. So first we kind of need to define a ratio. And a ratio is just a comparison using division. So for example, there are 4 men and 3 women in the class. In my class. So the ratio of men to women is 4 to 3, or 4/3, or you could write 4 to 3, but as a division, it's 4/3. The ratio of women to men then would be 3/4. Okay. Okay. So you probably saw. I think you usually see that in 0950. I don't remember. It's been a while. Anyways, a proportion is basically just 2 ratios being equated. So a proportion is basically you have a fraction on one side and then some other fraction on the other. Okay. Ratio 1 equals ratio 2. And you could use proportions to solve all kinds of problems. In particular, let's take a look at this tax problem. Okay, and the key to these problems, so that was 17, is to align the units in the tops and bottoms. So the tax on a property with an assessed value of $52,000 is $875. Using a proportion, find the tax on the property with an assessed value of $121,000. So over here, I'm going to put tax, and then on the bottom, I'm going to put price. Okay, so the tax, $875 for a $52,000 house. Okay, and then on the other side, I put, make sure you put tax on the top and price on the bottom. So the price of the other house is $121,000. You don't put it in the numerator, you put it in the bottom, just like on the other side of the proportion. And the numerator, we don't know. That's what we're looking for. We don't know the tax. Okay? And so long as everything's lined up like that, all you then have to do is cross multiply and get your answer. Okay, so that times that. So I got, and one issue is kind of with scientific numbers. It seems to be an issue for people. On the scientific calculators, especially, multiplying out 875 times 121,000 becomes an issue. Let me zoom over. So usually I just leave it like it is and then divide both sides by the 52,000 and then put it in my calculator. So don't multiply it out because it's going to give you funny answers like whatever. I'll multiply it out. Let's see what 875 times 121,000. Oh, it gave me the answer. Okay, well, it's a huge answer, okay? It's better just to type it in all at once using your parentheses and stuff like that. So, you go to your calculator and it has little parentheses buttons. So for the numerator, put it the whole numerator in parentheses. So 875 times 121,000 and parentheses. And then divided by 52123. Okay? And then to 2 decimal places, 2036.06. 2036.06. Okay. Okay. There was one that had huge numbers in it. I just want to find that one. Oh, here, this one. So in this problem, we have a global village. In a global village, so like in I don't know, some village somewhere, everybody maybe in I don't know where, but everybody's starving in this city or this village. There's only 250 people in the village, but out of that 250, 30 are starving. Okay. They want you to use that sample in order to estimate how many people are suffering on our planet. Okay, so we don't know how many people on the planet are suffering, but we do know the population. Okay, so we could put 6.9 billion down here. So 6, 2, 3, that's 900 million. Okay, so with a bunch of zeros like that. Okay, then we can cross multiply, and this is where you're probably going to have a problem with your calculator. So you have 250x equals that huge number. So let's see what the calculator can do that one. 30 times 6900000000. Yeah, so now the answer, it says 2.07 times 10 to the 11 is literally what it says on my some calculators go 2.07 E11, which means the same thing. It basically just means move that decimal over 11 places. So it's going to be 2.07, and then you move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is what would go there. Okay, what I'm saying is don't even bother with that. Just use the parentheses in your calculator to do it all at once. So you would have parentheses 30 times 6900000000, end parentheses, then divided by the 250. Okay, and then you get a reasonable number here, 828 million. Something to note is here in the answer, they don't want 828 billion written out like this. They want it in terms of billions. So you see my answer, it's actually 0.83, right? In terms of, this would be the thousands place, and then this would be the millions place. The billions place would be up here somewhere, okay, right here. So in terms of billions, it's really x equals 0.828 billion. That's the answer they want. Okay, so you could divide this answer by billion, by 1 billion, and that would give you your answer. What do they want? You have to round it to the nearest hundredth. So you could say x equals 0.83 billion. Okay, so hopefully that helps a little. It's harder with those big numbers. Okay. Sampling in nature, so it's basically the same kind of problem, except now you have like a so you're using tagging to figure out how many animals are in an area. So you'll tag a bunch of animals, so you put tags maybe on like 10 animals, and then you don't know how many animals are in the city. Okay, so maybe you're thinking about stray cats or something, and you collect 10 of them, and you put a tag on each one of them, and you let them back out into the city. Then you take a sample of the city's cats, and let's say you have you sample 100 cats, and out of that 100 you find that 5 of them have tags. Okay, you're able to figure out how many animals are in the city by doing that. So you just cross multiply, you get 5x equal 1,000, and then x would equal 200. Okay, so you could approximate 200 cats. So in general, when you're doing sampling in nature, it's kind of like that idea. So again, what you're doing is you're tagging a bunch of animals. Then there's the number of animals in the population, which is unknown. And on the other side, you're kind of doing a sample. So you're picking up a bunch of animals. So you maybe collect 100 animals, and then you're seeing how many of them have tags. Okay, and from this you could figure out the total population. Okay, so I hope that makes sense. Let's try it. in one of these problems. Okay, so here they have an island with 12 fur seal rookeries. Okay, so places where they breed seals. In particular, they're worried about Rookery A, and Rookery A, they took 6,743 seals and tagged them. Okay, and then they put them back into the rookery, and we don't know how many seals are actually there. Okay, so that, but we do now know that 6,743 of them have tags. Okay, then later on, I guess later in August, so in the beginning of August they tagged them and then released them, and then later in August they took a sample, right? They took a sample of 700, so there's 700 in that population sample, and then they found that 280 of those have the tags, and then they want you to figure out how many, what's the total number of seals in the rookery. So you just go ahead and cross multiply. I'm not going to multiply it out, I'm just going to figure it out in my calculator. 700, and then divide by 280. Okay, so in this case x is equal to, let me clear this out, 6743 times 700 with parentheses around all that, divided by 280, and I'm getting a lot, 16,000, 100. Really? Did I miss? I think I accidentally typed it in wrong. Hold on. Oh, I got it. 16857.5, and then if you round, it's 16,858 seals. Okay, they want you to round to the nearest whole number. Okay, so hopefully that is clear. Okay, so the next topic is similar triangles. Let's see what Roman numeral I'm on. 3, 4, I guess. And basically, you can make proportions based on the sides of the triangle, so long as it has corresponding angles. Okay, so so you're going to have two triangles, one bigger than the other, but they have corresponding angles. So this angle here is the same as this angle here. Okay, this angle here is then the same as this angle here. And then this angle here is the same as this angle here. If that's true, then the sides of these triangles are corresponding sides, and you can make proportions out of them. Okay, so let's say the sides of this triangle A, B, and C, and then the sides of this triangle D, E, and F. Okay, the corresponding sides are, so if this angle here with the two marks on it corresponds to this angle over here, then the corresponding sides are directly across from those angles. Okay, so A corresponds to D, and you can make a ratio, and then on the other side you can make another a ratio from corresponding sides. Okay, so you could say side C corresponds to side F. Okay, and likewise you could go A corresponds to D, and on the other side you could put then the other pair across from this first angle. B corresponds to E. Okay, so let's try this one in some of the exercises here. If I can find one. There's one. And there's more than one way to do these, and you'll as you go through the exercise and the homework, you'll sort of see that. Anyways, we have 44, 52, 12. These are two corresponding triangles. 11, 13, and X. So I can go, and make sure you get the correct sides. So this triple That's not the way they do it, though, is it? They put like an angle and then they put some tick marks in it. I'm just trying to be consistent with what they do. Okay, so this angle, they put like 3 tick marks in it, and this angle are corresponding. So you could say 11 is to 44, and I mean visually you can kind of see it. And on the other side, we could put the corresponding sides x and 12, right? So with that corresponding angle, the corresponding sides will be x and then 12. So make sure you're putting them in order. So this number here comes from the small, and this number is the big. So, and the fraction on the other side, the numerator should be the small, and then this is also the big. Okay, and then you could cross multiply. Numbers aren't too big this time. 44x equals 132. And then divide both sides by 44. So 132 by 44, whatever that is. Three. Fantastic. So I think we can handle that. We can do that. Okay, so we can do that. I think we'll be good then. Yeah, I guess we could try this one. Tree casts a shadow 18 feet long. So you have a tree of some sort casting a shadow. So the sun is out here somewhere and it casts a shadow which is 18 feet long. Okay. And then you have a vertical rod and it's casting a shadow 6 feet long. So the sun is casting a shadow. And this becomes important because if you're so we need to know the height of the tree. If you ever have trees and a tree is about to fall on your house, you have to have a tree company come out and take the tree down if it's really big. And the tree companies charge by the height of the tree, believe it or not. And if you don't know the height of the tree, they could pretty much tell you whatever they want and take your money. Okay. But if you do some trick like this and figure out the height of the tree, like just get a 16-foot pole like everybody has in their backyard, no, just use yourself, like a 6-foot human, and then find your shadow. If you can do that, you can figure out the height of the tree. You can use math to verify that people aren't cheating you. Okay, so anyways, this angle, we can get 16 on one in the top and x in the bottom. And then the sides corresponding to this angle. The small one is 6, the bigger one is 18. Okay. Cross multiply, 6x equals 16 times 18, whatever that is. $288, and then divide by 6. And apparently 48. It's kind of not that tall. I think big trees are like 70, 80 feet. Okay. They have these kind of. This one's kind of weird. The ratio of corresponding sides of two triangles is 1 to 1. Okay, so you have two triangles again. You don't know anything about them, but you do know that if you make a relationship between these two sides, the ratio, the fraction, x over y is equal to 1 over 1. What must be true about the triangles? Well, if you cross multiply, you'll see that these two sides must be exactly the same. So the corresponding sides to these corresponding angles here are the same, and that's what I picked there. The corresponding angles of the two triangles have the same measure, and the lengths of the corresponding sides are equal. Okay, so that's similar triangle stuff. Is that it? I think that's pretty much it. and I've hit a lot of these problems in here. Um, this is one of those weird ones where instead of a plus you have a minus. Okay, if one person is working against the other. And I kind of did these. Okay, I think that'll do us. Thank you for watching as usual, and I will see you next time.